Hi, welcome to Professional Certifications channel. Let's break down CISSP exam preparation, one topic a day for focused and effective learning. Today's topic is key management.
Definition. Key management is the process of handling cryptographic keys throughout their lifecycle from creation and distribution to storage, rotation, and destruction. Effective key management is critical for maintaining the security and integrity of encryption systems, ensuring that cryptographic keys are properly protected and used in a secure manner.
Key concepts.
1. Key lifecycle. Key management involves several stages that are crucial for maintaining the security of cryptographic keys throughout their lifecycle. Key generation. Cryptographic keys must be generated using secure methods to ensure they are random and unpredictable. Weak key generation methods can produce keys that are vulnerable to brute force attacks. Random number generators, RNGs, or pseudo-random number generators, PRNGs, are used for key generation. Hardware security modules, HSMs, or software libraries can be used to securely generate keys. Key distribution. Keys must be securely shared with authorized parties. Improper key distribution can lead to interception and unauthorized use. Asymmetric encryption is often used for securely exchanging symmetric encryption keys, e.g., in the TLS protocol, RSA is used to exchange symmetric session keys. Secure channels, such as VPNs or SSH, are commonly used to distribute cryptographic keys. Key storage. Keys must be stored securely to prevent unauthorized access. Keys should never be stored in plain text and should be protected using encryption or hardware security. Hardware security modules, HSMs, are commonly used for securely storing cryptographic keys. They provide a tamper-resistant environment and are widely used in sensitive industries like finance and government. Software-based key stores also provide encryption for keys at rest, but HSMs are more secure. Key usage. Keys should be used only for their intended purpose and within the context of specific cryptographic operations, e.g., encryption, decryption, signing. For example, a key intended for encryption should not be used for digital signatures. Enforcing least privilege principles ensures that keys are only accessible to the systems or individuals who need them for specific tasks. Key rotation. Keys should be rotated or renewed periodically to reduce the risk of compromise. This means replacing an old key with a new one, while securely decommissioning the old key. Automatic key rotation mechanisms can be implemented to ensure regular and consistent key updates, reducing exposure from long-term use of a single key. Key expiration. Cryptographic keys should have a predefined expiration date to limit their use over time. Expired keys are no longer used in cryptographic operations and are replaced with new keys. Key expiration helps mitigate the risk of compromise and forces regular key rotation. Key revocation. If a key is compromised or no longer needed, it must be revoked to prevent further use. The revocation of public keys is often managed via a certificate revocation list, CRL, or online certificate status protocol, OCSP, in a public key infrastructure, PKI, system. Key revocation ensures that compromised keys cannot be trusted by other systems or users. Key destruction. When a key is no longer needed or is compromised, it must be securely destroyed to prevent future use. Secure destruction ensures that no residual copies of the key remain accessible. Key destruction may involve overwriting memory where the key was stored or using hardware destruction techniques for physical media.
2. Types of cryptographic keys. Symmetric keys. Used in symmetric encryption, e.g. ECDH, where the same key is used for both encryption and decryption. Symmetric keys must be securely shared between the parties involved in the communication. Asymmetric keys. Used in asymmetric encryption, e.g. RSA, ECC, where a public key is used for encryption and a private key is used for decryption. In public key infrastructure (PKI) systems, asymmetric keys are used for secure key exchange, digital signatures, and authentication. Key exchange keys. Keys specifically used to exchange or share encryption keys over an insecure channel. The Diffie-Hellman (DH) protocol is commonly used for secure key exchange. Session keys. Temporary symmetric keys used for a single communication session. Session keys are typically generated for short-term use and are discarded after the session ends to enhance security.
3. Key management protocols. Key Management Interoperability Protocol, KMIP. KMIP is an industry-standard protocol designed to simplify key management by enabling communication between key management systems and cryptographic devices. It allows for consistent and secure management of cryptographic keys across multiple platforms. Secure Key Exchange Protocols. Diffie-Hellman, DH, a widely used algorithm for exchanging cryptographic keys securely over an insecure communication channel. Elliptic Curve Diffie-Hellman, ECDH, a variant of Diffie-Hellman based on elliptic curve cryptography, which provides similar security to DH but with smaller key sizes.
4. Key Escrow. Key escrow is a system in which cryptographic keys are held by a third party, known as the escrow agent, who can provide the keys to authorized entities under certain conditions, e.g., law enforcement access. Key escrow can be used in environments where there is a need for key recovery, such as in the event of a keyholder's inability to access the key. Risks. Key escrow introduces potential vulnerabilities because the third party holding the key may be compromised. The key escrow agent must be trusted and implement robust security practices to prevent unauthorized access.
5. Key Wrapping and Key Encryption Keys, KEKs. Key wrapping. Key wrapping is a process where a key is encrypted using another key, often called a key encryption key or KEK. This protects the key being wrapped while allowing it to be securely transported or stored. Key encryption keys, KEKs. KEKs are used to encrypt other cryptographic keys, ensuring their confidentiality during storage or transmission. KEKs are typically stored in highly secure environments, such as hardware security modules (HSMs).
6. Key management in cloud environments. Cloud service providers often offer key management services, KMS, allowing organizations to generate, store, and manage encryption keys in the cloud. Examples include AWS KMS, Google Cloud KMS, and Azure Key Vault. Customer managed keys, CMK in cloud environments. Organizations may retain control over key management by generating and managing their own keys rather than relying on the cloud provider's key management infrastructure.
7. Best practices in key management. Use strong keys. Always use secure key lengths. For example, AES 256 for symmetric encryption and RSA 2048 or higher for asymmetric encryption. Regular key rotation. Regularly rotate cryptographic keys to limit exposure in the event of a compromise. Limit key exposure. Only allow the minimal access necessary for key operations, and ensure that cryptographic keys are only accessible to authorized users and systems. Use HSMs. Use hardware security modules to generate, store, and manage sensitive cryptographic keys, especially in high-security environments like financial services and government. Key backup. Ensure secure backup of cryptographic keys in case of disaster or system failure. Backups should be encrypted and stored in secure locations.
Importance in the CISSP exam. Key management is a core topic in the security engineering and identity and access management domains of the CISSP exam. CISSP aspirants must understand the key lifecycle, secure key generation and distribution, the use of hardware security modules, HSMs, and the importance of key rotation and revocation. Exam questions may focus on real-world scenarios involving secure key exchange, key storage practices, and the risks of improper key management.
Real-world example. In an enterprise VPN, symmetric encryption, AES 256, is used to protect communication between remote employees and the corporate network. The session keys for these VPN connections are generated at the start of each session and are securely exchanged using RSA, asymmetric encryption. These session keys are automatically rotated for each session to enhance security.